Hello everyone, welcome to video lecture series of radar systems. Today's topic is staggered pulse repetition frequency. The commonly used term is staggered PRF. In this video, I'll be talking about what is a staggered PRF, how multiple PRFs can be obtained, what are the various methods and some of the important terms. Let us begin. If a radar is operating at multiple PRFs means pulse repetition frequency, or its pulse repetition frequency is changing either pulse to pulse or scan to scan, then the effect of blind speed can be eliminated. See, we have discussed the effect of blind speed in the case of the MTI radar. What happens? See, blind speed is a major drawback of the MTI radar. That is a serious problem. What happens? When Doppler shifts is equal to the integer multiple of PRFs, then the delay line canceller not only eliminate the DC component which is caused by the clutter, but it also rejects the moving target. Means the response, the frequency response of the delay line canceller, that becomes 0 on that particular point. So those points are treated as a blind points. So if multiple PRFs can be utilized, then that particular effect of blind speed can be eliminated. And PRF can be changed from pulse to pulse, and if the PRF is changing from pulse to pulse, then it is known as a staggered PRF, a staggered pulse repetition frequency, about which we are talking in this particular video. The use of more than one pulse repetition frequency, it offers additional flexibility in the design of moving target indication Doppler radar filters. So it provides the flexibility so that it can be work efficiently, and it not only reduces the effect of blind speed. We have discussed the effect of blind speed, means that is being reduced by the staggered PRF. So this is one function or the one advantage, but besides it, it also allows a sharp low frequency cutoff in the frequency response, which might be obtained with a cascaded single delay line canceller. So there are various advantages of staggered PRF. Staggering of PRF is generally employed in air traffic control radar like surveillance radar element SRE. So you can see how much important this staggered PRF. So this is commonly employed in the air traffic control. Here you can see the frequency response. Here two PRFs have been shown. One is F1 and second is F2. F1 is being drawn with the help of the red line and F2 with the help of the blue line. So on the x-axis frequency is being taken and on the y-axis amplitude is being taken. So you must remember F1 with the red and F2 with the blue one. Just for the indication, it has been mentioned in this particular diagram. If you observe the behavior of this red and blue lines, means the frequency response of these two PRFs, then you can observe over here, there will be a point when these two pulse repetition frequencies will be equal, and that particular point is this point. At this particular point, both the PRFs, means 2F1 that is equal to 3F2, both the PRFs are same, means they have the same blind speed, right? So that is what you can observe from this particular frequency response. And multiple PRFs can be obtained by using various methods and some of the common techniques which can be employed to vary pulse repetition frequencies, that are pulse to pulse, scan to scan, or dwell to dwell. So these are the various ways via which multiple PRFs can be obtained. But the problem actually occurs in using staggered PRF, that is the residual of uncancelled echoes of clutters. And the residual of uncancelled echoes of clutters, which is actually due to the second time around echoes. It means to minimize second time around echoes effect, if we use unstaggered staggered PRF in the sector, where second time echo around that are expected more, and the rest of the sector which uses the staggered PRF. So there are variations depending upon the requirement, depending upon the applications it could be utilized. Now let us discuss about the subclutter visibility. Subclutter visibility, this is denoted by SCV. This is a very important term. So subclutter visibility, it defines the ability of a radar to detect moving target when the moving target is embedded into a strong clutter background. Means there is a target that is moving, but in the surrounding there will be certain stationary, non-moving clutters. It may be some building or mountain or anything that could be. So it actually describes how much capable the radar is to detect the moving target. SCV, it is often used as a measure of effectiveness of an MTI radar, and it is measured in dBs. And the subclutter visibility, this is nothing but the ratio of improvement factor. Improvement factor is denoted by I to the MTI output, SCR. SCR is signal to clutter ratio, which is required for the proper detection for a given probability. And this output SCR, it must be minimum. So the subclutter visibility, mathematically it can be written as what? I upon SCR at the output. Similarly, you can define the improvement factor also. Improvement factor is denoted by I, and this is the ratio of signal to clutter ratio at the output of clutter filter divided by signal to clutter ratio at the input of the clutter filter. So you can see what is I, signal to clutter ratio at the output upon signal to clutter ratio at the input. Subclutter visibility, this is a very important factor you can explain by taking an example. Let us say, or let us consider that if MTI radar has a SCV, its value as 20 dB. It means a moving target can be detected in the presence of clutter even though the clutter power is 100 times the target echo power. So even see how much clutter power is stronger than the echo, even then it can identify the moving target. So this is how you can explain it. Next is the cancellation ratio. Cancellation ratio, it is actually defined by a ratio which is used in various applications of the radar, which describes the degree to which backscatter power from the unwanted target. Unwanted targets are actually the clutters that is suppressed or cancelled in one mode measured related to the other mode. And this is very simple to define, that it is a ratio of fixed target signal voltage using MTI cancellation to the signal voltage without MTI cancellation. Means using MTI cancellation upon without MTI cancellation. And the value of cancellation ratio, this is always less than 1 and it can be expressed in dB. So mathematically also you can write down, this is the fixed signal target voltage using MTI cancellation upon without MTI cancellation. Next, one more important factor is the target visibility factor. The target visibility factor, this is the ratio of the signal strength from a target which is moving at a specified radial velocity to the signal strength from the same target when it is moving at an optimum radial velocity. So this is also a ratio, and it defines the capability of a target visibility, which actually related with the radar performance. So this is how you can explain and you can relate the parameters.